Hi there. In this video, we'll see taints, tolerations, and affinity in action. Now, I'll try to keep the theory to a minimum because I want to show this as part of a demo where it will be more clear. Now, what are taints? It's used to basically repel pods from the nodes, preventing unwanted workloads from landing on specific nodes unless the pod has a matching tolerations. Now, how does taint works? It always works in tandem with tolerations. The first step is you taint the node. Basically, you apply a key value pair with the effect to a node. For example, kubectl taint nodes the node name and then followed by the key value pair and a effect. Here it's no schedule. Second, pod toleration. You define a toleration in the pod spec to match the taint. For example, tolerations key and then the same key value pair that you define in the taint and the operator would be equals. Now there can be three different taint effects. One is no schedule, which basically prevents new pods without a matching tolerations from being scheduled. In the demo, we'll be taking a look at no schedule, the first one only. The second one is prefer no schedule. This is a soft preference. The scheduler tries to avoid scheduling non-tolerating pods, but can still go ahead and do so. The third one is no execute. The new pods without the matching tolerations are rejected, as well as any existing pods that do not tolerate are also evicted. Now coming to node affinity. Node affinity is a scheduling feature that influences which nodes a pod is eligible to run on based on labels applied to the nodes. The types of node affinity are required during scheduling, ignored during execution. This is a hard rule. Kubernetes scheduler will only place a pod on the node if all the specified affinity criteria are met. If no matching node is found, the pod will remain in a pending state. The second type is preferred during scheduling, ignored during execution. This is a soft or the best effort rule. The scheduler will try to find a node that matches the affinity rules, but if it cannot, the pod will still be scheduled on any available node. This offers more flexibility and reduces the risk of unschedulable pods. Now, similar to node affinity, there's also pod affinity and anti affinity. These basically allow you to constrain which nodes your pod is eligible to be scheduled, but based on the labels of other pods running on that node. But as part of today's demo, we'll only be focusing on node affinity. By combining taints and node affinity, you get powerful granular control over where your pods run in your cluster. Let's dive into demo. So I'm on my Docker desktop right now. Let's take a look at how many worker nodes we have. So we run kubectl get nodes. As you can see, there are two worker nodes here, desktop worker and desktop worker 2. Now let's take a look at the two applications that we have. So the first one is a simple Nginx application. The idea is this is a regular application which can run on any node. And then I have another deployment which says Nginx GPU. Now hypothetically assume that this is an application which needs GPU specific worker node. So this should ideally run on a separate worker node which can run GPU specific loads. Now let's see how we can achieve this. Now let's go ahead and deploy both the deployments. In the top pane here, this is continuously watching for new pods that are getting deployed. So now I'm going to run kubectl apply-f deployment 1.yaml. So at the top here, you'll see two pods getting deployed. You see there are two instances of the regular Nginx application. The one of the instance went to desktop worker. The other one went to desktop worker 2. Now, similarly, let's deploy the second application. This should also create two more pods. As you see, the GPU specific, there are two more instances running, and one of them went to desktop worker 2 and the other one went to desktop worker. Now, as we said, our goal is to have GPU specific application to only run on desktop worker 2. Right now it's running on both the worker nodes, and the same is case with the regular Nginx, which also runs on both the nodes. So now let's see how to isolate the GPU specific application to run only on desktop worker 2. Let me go ahead and delete this application. Deleting deployment1.yaml and now deleting deployment2.yaml. Both should be gone from the top pane now. So as a first step, let me go ahead and taint the node. The command that I'm going to run is kubectl taint nodes desktop dash worker 2, and I'm going to taint it with the key value pair app equal to GPU and effect as no schedule. So the worker nodes are tainted now. So let me go ahead and redeploy both the applications and see what the behavior is now. So what that taint essentially done is it will repel any pod which doesn't have the corresponding toleration specified. So let's see the behavior. Deploying the first application. It's deployed, and as you see, both the regular instance of Nginx are deployed on desktop dash worker. Earlier, one instance went to desktop dash worker and the other one went to worker dash 2. But right now, both are going to desktop dash worker. So let's see what's the case with the other deployment as well. Deployment to both instances created as well, and here in this case as well, both went to desktop dash worker. So what that taint does is it doesn't allow any of the pods to be deployed on that node because none of the pods has tolerations which can tolerate the taint. This is still not achieving our goal, which was to have GPU specific instances run on the worker 2 node. Now let's see how we can achieve that. Let me again delete the two applications. Now the node is tainted. As a next step, what we are going to do is in the deployment 2, which is the GPU specific application, I'm going to add a toleration where the key will be app, the value will be GPU, the operator is equal, and the effect is no schedule. This basically matches the taint that we have added on the node. And let's deploy this and see what the behavior is. I'm going to deploy application 1 first. There should not be any change here. It should still go to the desktop worker node. That's what we see here. Now we deploy the deployment 2.yaml. So here what we are seeing is one of the GPU instances went to desktop worker 2. The second instance went to desktop worker. Now why is that? We had added a toleration here, but why did it still go to desktop worker? Now that's because the desktop worker node doesn't have any taint specified. So technically any pod, whether they have specified toleration or not, can be scheduled on such nodes. So that's why you see here one instance went to desktop worker and the other went to desktop worker 2. Now this is still not achieving the goal we had in our mind where the GPU should only go to desktop worker 2. Let's check as a next step what we can do to achieve that. Now we'll have to use a combination of taints and tolerations and node affinity to achieve our final goal. Now let's see how to do that. Before that, let me clean up the applications again. Now before I can use node affinity, I'll have to label the required node with a specific label that can be used along with node affinity. So what I'm going to do is I'm going to run this command kubectl label nodes desktop dash worker 2 to specifically add a label with a key value pair app equal to GPU on this particular node. Now the label is applied. Now as a next step, I'm going to modify the deployment 2.yaml, which is the GPU application, and add under the spec section affinity, node affinity, required during scheduling, ignored during execution. The node selector terms and match expression should match the key value pair of the label that we just added. So the key would be app, the operator is in, and values is GPU. So this should match the label that we added to the node. Now let's go ahead and deploy this both the applications and see what the behavior is. Deploying the first, there should be no change in the node that this gets deployed to, and that's expected. Now let's deploy the second one. Now in this case, you see that the GPU nodes, both instances went to desktop dash worker 2. Now this is what we wanted. This was what our goal was. And the other regular pod went to desktop worker. Now let's try and increase the number of replicas for GPU and see if all the instances still go to the expected node, which is the worker 2. Now I'm going to scale the deployment of GPU apps to 4 replicas. It should add 2 more nodes, and as we see, all the 4 GPU instances are running on the worker 2 node, which is as expected. So this is how we can use taints and tolerations in combination with the node affinity to direct any particular pods to the specific nodes that it is supposed to run on. So that's all I had as part of this video. Thanks for watching.